Hey everyone, 6.4, the quadratic formula. This is something that you're going to use in math going forward quite a bit. So this will kind of be like a y equals mx plus b. When you see it, when you see y equals mx plus b, you know linear equation, straight line. When you see the quadratic formula, you know that you're going to be dealing with a parabola. We've dealt with standard form, we've dealt with factored form, we've dealt with vertex form. And they're all methods of graphing a parabola. We're going to look at a method that works in all cases right now, and that's called the quadratic formula. The quadratic formula is as follows. X is equal to negative b plus or minus the root of b squared minus 4ac all over 2a. So a bit of a dirty looking formula, but quite easy to use. It's plug and play. I'm going to draw your attention to sort of this part of the formula. And this part of the formula is the x-coordinate of the vertex. So the x-coordinate of the vertex, if you just do minus b over 2a, you will find the x-coordinate of the vertex. And therefore, this here is the formula for the axis of symmetry. So that's that part of the formula. Let's go over this formula a couple times and just become familiar with it. So if I give you a formula in standard form, minus 3x squared plus 4x equals negative 5. First of all, we can put that into standard form. So minus 3x squared plus 4x plus 5 when we move that to the other side of the equal sign is equal to 0. And we can see here that our a is equal to negative 3, our b is equal to 4, and our c is equal to 5. So let's plug that into our formula. We have x is equal to negative b plus or minus b squared minus 4ac all over 2a. So our b here is 4. Now here's the key. This is a minus b. So sub in just for the variable. So I'm going to keep that minus. And for the b, I'm going to sub in 4. We don't want to lose that. Plus or minus the root of, once again, 4 squared minus 4, negative 3, 5. So I'm subbing in just for the variables, and that's all over 2, negative 3. Negative times 4 is negative 4 on the outside of this. And on the inside here, remember bed mass, so this would be 16 minus 4 times minus 3 is positive 12 times 5 is positive 60 all over negative 3. I would imagine that you would do some of this a little bit quicker. I'm writing it out. One especially right here to show you that don't forget bed mass. So we have this minus this, but these are timeses. So make sure you're doing that in the correct order. Continuing to simplify, minus 4 plus or minus the root of 76 all over minus, oops, this is a minus 6 back here, all over minus 6. All right, done. And I know that looks dirty, but we are just trying to find out what this formula does is it lets us know what the roots are. And remember, roots are equal to the zeros of the equation, which is equal to basically where does this parabola cross the x-axis. So this is our answer, and I'm going to take it one step further. So these are the exact roots. And the exact roots are this parabola crosses the x-axis at two places. It crosses here at minus 4 plus root 76 over negative 6, and minus 4 minus root of 76 over negative 6. So those are known as exact roots. We leave them in this form. And that's exactly where they cross. They cross at minus 4 plus the rest of this and minus 4 minus the rest of this. Hence the plus minus. Now sometimes you will figure out the approximate roots. And that's usually if you're going to graph. And the approximate roots is when you actually do this math. So you find out what the root of 76 is. So minus 4 plus the root of that. And I believe we get here answers of 0.7862 and 2.1196. So these are the two places that our parabola crosses the y-axis. If we had a little Cartesian plane here, and this is 1, and this is 2 on the x-axis, and this is 3, we know this is crossing at 0.78, which would be right around here somewhere, and 2.11, which would be right around here somewhere. All right, so that is that. Usually we're just figuring out exact roots unless it's asking for approximate roots. So you can leave it at that stage. All right, let's do another example here. So y is equal to 4x squared minus 12x plus 9. So let's find the x-intercepts. Let's find the vertex. And let's find the equation of the axis of symmetry. And fourth, let's sketch this puppy. All right, so first of all here, I can see that my A is equal to 4, my B value is equal to negative 12, and my C value is equal to plus 9. Let's put that into our formula. So we have minus B. So minus, and B here is minus 12, so subbing in minus 12 for the B. Plus or minus, we have our B squared minus 4A squared, so negative 12 squared minus 4. Four. 9, sorry, all over 2a. All right, simplifying this, negative 12 is, or negative 1 times negative 12 is, we get a positive 12 plus or minus 144. Negative 12 times negative 12 is 144 minus 144 when we simplify all that, all over 8. So 12 plus or minus the root of 0 over 8. So our roots are, we only have, in this case, one root. So we have 12 over 8. And if we were to graph that, that of course would be equal to 1.5. So we know our x-intercept here equals 1.5 and 0. Our vertex. I guess actually we figured that out. So our vertex is at 1.5. We can use our formula for that. Let's try this out. Minus b over 2a. Actually, let's put this out front here. So b is minus 12 over 2 times 4 minus 12 over 8. And actually that's a minus 12, which is equal to a positive 12 over 8 or 1.5. So that shows you how that part of the formula can be used to find the x-intercept. Now this answer right now is the same as this answer, and the reason is is we only have one root in this case. So our one root, so here's 1, 2, our root is 1.5. So we only have 1, 0, 1 root, 1 x-intercept. So that's how that comes about. All right, another example here. Y is equal to x plus 6 squared. All right, we're looking at this, and this looks like it might be in factored form. Sort of a y equals x plus 6, x plus 6. So it kind of is factored form. And you can see from here that we would only have one root. This is actually, though, in vertex form. So this is a factored form equation the way it's right now. We've kind of, but it's in factored form. So our vertex here, we can see where our vertex is. We know our vertex is at -6, or the full coordinates of it is -6, 0. So remember, if this is in factored form, we know that we don't have an a value, there's no stretch or compression. We know that this is moving to the left 6 spots. So here's our original parabola. It doesn't stretch or compress. It moves 6 spots to the left, and we don't have a k value. So it's just sitting out over here with one vertex. Likewise here, if this was in standard form, we know our vertexes would be -6. They're both the same, so that tells us that we only have one of them. So we know that we are opening up, and we only have one vertex. Now, can we tell from our initial equation how many zeros or how many roots we have? Whether we have no roots, one root right here, or 2 roots. So we call that the discriminant. And in the quadratic formula, the discriminant determines the number and type of roots. And the discriminant is, b squared minus 4ac. So you're probably recognizing that as part of our original quadratic formula. This part here is called the discriminant. And if you evaluate just that, not including the root, but just this, that'll let you know how many roots you have and the type of them. And here's the deal. If this here is greater than 0, you're going to get 2 real roots. If the discriminant is equal to 0, 1 real root. And if it is less than 0, no real roots. So in an equation like 4x squared minus 7x minus 1 equals 0, we know a is equal to 4, b is equal to -7, c is equal to -1. We can use our discriminant formula here, b squared minus 4ac. b is -7, so -7 squared minus 4 times a, which is 4, times c, which is -1. -7 squared is 49. Minus 4 times -4 is -16. Times -1 is +16. And we get an answer of 65. 65 is greater than 0, so we have 2 real roots. So we can determine how many roots we have by using just that part of the formula. All right, let's do one word problem here using the quadratic formula, and then we will call it a day. So path of a soccer ball. Path of a ball. It's kicked from a height of 0.5 meters. So the ball is kicked when it's half a meter off the ground. And the equation of the path of the ball is the height is equal to 0.1 d squared plus d plus 0.5. So substituting in other letters for height and distance. So 1, let's find out how far the ball travels. And B, let's find the horizontal distance when the ball is 2.6 meters off the ground. So if we were to graph this, we have our Cartesian plane here, we have the height of the ball, the distance of the ball. We know the ball is kicked from half a meter off the ground, and it travels and eventually hits the ground. We know it's a parabola. So even though this part of the parabola wouldn't exist in real life, mathematically it does. So let's work through this. So we have here our formula. And this is a formula, of course, when the height is 0. If we want to find a different height, we can sub it in. Our A value here is -0.1, our B value is 1D, and our C value is 0.5. So we can sub this into our formula. (b plus or minus b squared minus 4ac all over 2a. Sub in everything. (1 plus or minus 1 squared minus 4 times 0.1 times 0.5 all over 2. Something like that. Simplifying, we have distance is equal to (1 plus or minus 1 plus). When you figure all that out, it's 0.2. And 2 times (-0.1) is (-0.2). So D is equal to (-1 plus or minus 1.2) when I simplify this, all over (-0.2). So that's our two exact roots. We have D is equal to (-1 plus the root of 1.2 over (-0.2), and D is equal to (-1 minus . Now, in this case, so these are exact roots. If we figure out our approximate roots, we're gonna get (-0.5 on this side and a distance of 10.5 on this side. So this here is our answer. This ball lands at 10.5. It also crosses the x-axis at (-0.5 out here. However, we know that we cannot have a negative distance. So a negative distance in this case is not possible. The flight of the ball is our solid line. The dotted line is just the rest of the mathematical parabola, but the solid line is the only possible path of the ball. We can't have a negative height, I guess, unless you're kicking it into a hole, and you can't have a negative distance. So this is our answer right here. So that is how far the ball travels, 10.5 meters. Find the horizontal distance when the ball is 2.6 meters off the ground. So for part B, we want to know when the height is 2.6. So we can put that into our formula. 2.6 is equal to (-0.1d squared plus d plus 0.5. 0.5. So I took our original formula here and I put in a height of 2.6. And simplifying, I'm going to move the 2.6 to the other side of the equal sign. And it becomes a minus 2.6 over here. So if I just, so a minus 2.6 and a minus 2.6. We can do that, put it on both sides, equal sign. We haven't changed the equation because we've added the same thing to both sides, so the both sides are still equal to each other. So 2.6 minus 2.6 is 0, and 0.5 minus 2.6 is minus 2.1. So that's our C. So this, of course, is our A. This, of course, is our B. This, of course, is our C. So plugging it into our formula, we get -1 plus or minus 1 squared minus 4 times -0.1 times -2.1. That's all over 2 to -0.1 times -0.1. Beginning to simplify, plus or minus, 1 squared is 1. Simplify all that, you get minus 0.84 all over. And once again, I'm kind of breaking this step up, making sure that I'm doing bed mass properly. So we get our roots of here, or actually I'll put in the other line first. I won't skip steps with you. 0.16 when we simplify this, all over -0.2. So our two roots are -1 plus the root of 0.16 over -0.2 and -1 minus the root of 0.16 all over 0.2. So these are our two roots. If we want to get approximate roots, if we evaluate this, we get 3. If we evaluate this, we get 7. So what that tells us is, going back here, that at a height of, and if I was to redraw this parabola, so let's ignore this, at a height of 2.6, if you were to draw a line across at that height and drop down to the y or the x-axis, it would, at 3 meters, at a a horizontal distance of 3, it'd be at that height, and also at 7, it would be at that height. So that's what we figured out here, that when the ball is 2.6 meters off the ground, it'll either be at a distance of 3 meters or 7 meters from where it was kicked. All right, so that's a little bit of a run through of the quadratic formula. As I said, it works in all situations. I know you do have the skill set to evaluate this different ways. And, you know, going back to this question, we do have vertex form, we do have factored form. This is just yet another method of doing it. It's sort of a preferred method, a lot of mathematicians, because you can get those actual roots. This here is more accurate than this and this. So if you're building a bridge, or you're doing something where decimal places matter, where accuracy really matters, then you want the actual roots. If we're just applying it to a problem like kicking a ball, and if we're off by a little tiny bit due to rounding or something, no big deal. Then we can find out the approximate roots. All right, that's it. Have a great day, everyone.